about who my audience is. Raise your hand if you teach introductory economics. That's most of the hands in the room. Raise your hand if you're concerned about climate change. Most of the hands. Okay. Well, that's what I'm going to be talking about. So this presentation is about incorporating climate change into what you're already teaching in introductory economics. And what I'm going to recommend is that you raise this tough question. Should we burn more or burn less fossil fuel? The climate that has nurtured human civilization is slipping away, and the next 20 or 30 years are really going to be key in how that unfolds. And I think that when future generations write the history book, what they're going to have to say about this moment in history was how well we did or did not stabilize the climate. So an assumption in introductory economics, in intro we talk about the importance of assumptions. And an assumption in my class is that the CO2 that is emitted from burning fossil fuels is warming the climate. And I tell my students that this is an assumption that's based on mainstream science. And I encourage any students who want to debate the science to go over to the science building and engage any of our science faculty about that. So I don't engage in a debate about the climate change science in my economics classroom. This is the emissions history and cuts needed to remain probably under 2 degrees of global warming. And I'll have more, you'll see this slide several times, and I'll have more to say it as we go along. But for now, focus on the black line at the top. It shows the increasing level of emissions that we've actually had up until the present. And the area underneath that curve shows the total emissions. The area going down into the future, that area is the amount of CO2 we can emit in the future and stay within the carbon budget. And we need to stay within the carbon budget to likely remain within 2 degrees of global warming. And what the black line shows is one path, and it's the usual path, that is considered in how to reduce emissions to remain within the carbon budget. So if we stay within the carbon budget, how big a chance do we have of staying under 2 degrees Celsius of global warming? The answer is a 66% chance. So the best case is that we do cut emissions to remain within the carbon budget, that these cuts keep us under 2 degrees of global warming, and again, there's really only a 66% chance, is what the climatologists tell us. And third, that 2 degrees is good enough to avert catastrophic climate change. And the signatories to the Paris Treaty, or the Paris Agreement, in 2015 expressed that they did not think 2 degrees was good enough. Of course, climate change is already occurring. We see glacial melts and bigger storms, floods, more severe droughts, forest fires, ocean acidification, and warming with the bleaching of the coral reefs. The picture at the bottom is of a picture taken down at Miami Beach. And according to what I read, it's a regular occurrence that in Miami Beach, when the tide is high, that there's a flood. The seawater comes up through the storm drainage system, and people are walking and driving in a sunny day, flooding. Of course, all of these consequences are expected to worsen as the climate change continues to advance. So because it is economic activity that's causing it, I think climate change warrants being a focus in our economics classes. We in economics often talk about what's in the best interest of society as a whole, in the context of climate change, the society is the global society. So a restatement of the topic of the title of my paper is, to enhance the well-being of the global society, should the global economy decrease or increase our burning of fossil fuels? And that puts us right squarely in the discussion of negative externalities. And we often teach negative externality in the context of steel or aluminum or livestock or paint. And the familiar lesson from our teaching of externalities is that from the standpoint of society as a whole, we are producing too many of these goods. So we can reinforce the externality lesson and teach our students, bring it up for climate change. So I suggest that we can pose these questions to our students. One negative externality has been called the mother of all externalities, and what is that? What is that externality? What are the costs that are being externalized? And what market activities create these externalized costs? We can use the familiar externality graph and point out to them the lesson that to optimize the well-being of global society, we are to burn less fossil fuel. Then we can ask them, well, if it's that clear, if the externality lesson is that obvious, we need to burn less fossil fuel, why don't we simply burn less fossil fuel? I think just asking these questions of our students is a meaningful and easy way to include climate change in our courses. And in response to this last question, students will at least implicitly associate fossil fuels with powering the economy. And so I ask them, or I provide them with this data. And you see there the different sources of energy. And then for the different decades, the growth in each of these energy sources. So in between 84 and 94, fossil fuels grew by 17%. This is for the globe. The next decade, fossil fuels grew by 26%. And in the last decade, fossil fuels grew by 21%. And then at the bottom in the green, you see the phenomenal growth in the alternative energy category. And so after showing them this data, I asked my students, today, what percentage of our global energy comes from this bottom wind category? What percentage of our total energy today for the globe comes from that category? And I'll ask you just to make a mental note. Anybody want to guess? Got any guessers? Any takers? 7. Raise your hand if you think 7's probably about right. Raise your hand if you think 7's a little high. Raise your hand if you think 7's a little low. All right, so you were split into 4 groups, 7 about right, 7's low, 7's high, and not playing. So here's the answer. 2.4. So even after all that phenomenal growth, fossil fuels remain the source of energy that is powering the global economy. I give them a problem, and the problem is to figure out what the energy mix needs to be to remain within the carbon budget over the next decade. So for 2024, in the decade 2014 to 2024, how much growth do we need in that wind category in order to remain within the carbon budget? And so there's the question they get. And I give them data in order to do the math, working with percentages and arithmetic to solve this problem. And so the question is, how much does the wind category need to grow? To stay within the carbon budget, we need to reduce our fossil fuels by 20% by 2024. We need to reduce fossil fuels by 20%. Optimistically, nuclear does not decline any more than it has already. and optimistically, the wind source of energy can increase by 40%. So given those assumptions, what do we need from the wind category in order to maintain growth and stay within the carbon budget? And here's the answer. The wind category needs to increase from 319% improvement, expansion over 204 to 214 to a 1,409% increase. So by 2024, we need the wind category to grow from 2.4% to 31%. That actually is where I can get to in one day. And but again, I go beyond that, and I begin I look at the question of the possibilities for green growth. And to measure how climate-friendly growth is, we can look at the carbon intensity of GDP. So the fraction is with 35 gigatons of CO2 in the numerator and $80 trillion of global GDP in the denominator. Those are actual sort of representative figures, and that ratio is 0.44. And what we would like to have happen is that the numerator gets smaller, CO2 emissions go down, and we would like for the global GDP to rise, so we would like for that ratio to get smaller. So smaller is better, and the more negative it goes, better still. So then I ask my questions, ask my students the question, is this what has been happening? Has the carbon intensity of GDP been improving? Raise your hand if you think, yes, it probably has been improving. Our GDP is getting cleaner. Raise your hand if you think it has not been improving. Okay. Actually, it has. Happy to say. So we've been improving, and most of you said no, by the way, but it has been improving. So on a per dollar basis, we are reducing our emissions. The reason emissions continue to rise is because we're producing so much more GDP. So each dollar's worth is cleaner, but we're producing more dollars worth of GDP. But this 0.89 is the rate of improvement annually on average for the globe over those time, over 1994 to 2014. And I did pull out just the last 10 years, and the bad news there is our rate of improvement, it has slowed. Germany is often lifted up as an exemplar in this regard. So just to give you some perspective on that, there's Germany's annual rate of improvement, and it is clearly better than what we've done for the globe. But looking at just the last few years, in Germany, their progress has slowed as well. So what do we need? What rate of improvement in the decarbonization of GDP do we need in order to maintain global growth at the rate that we've had it, global growth in GDP at the rate that we've had it over the last 30 years? So how much cleaner does each dollar's worth of GDP need to get and stay within the carbon budget? So that's a question. And the answer is 4.84. So we need to improve from 0.89 average annual rate of improvement to 4.84. So that means from 2015 to 2050, we need to every year do a whole lot better than we've achieved in every year over the last 30 years. So that always, some people are undeterred by that. They believe that technology will save us, and I've had people pick up their cell phone and say to me, just look at what this thing can do. Technology is just unlimited in what it can do for us. William Nordhaus is a climate economist, a noted climate economist, I'll say, from Yale, and he answered this issue of what about electronics? And he said, but outside of electronics, there is no historic precedent for the rapid improvements that we need over an extended period of time. So, and as expressed by Another writer, the Electronics as an Outlier, Richard Heinberg says, had vehicle technology improved on par with a typical household computer, an automobile would be traveling 200 miles on each gallon of gasoline, and a new car would cost only $750. So as Heinberg says it, microprocessors are a special case. I'm going to close, a few more slides, but I want to just touch on some of the ethical issues around climate change. And this map shows the per-person emissions, and the red is where emissions on a per capita basis are high, and the blue is where they're low. And so the red folks are externalizing our cost onto other places. And this graph shows where the vulnerability is. So here the red means people are more vulnerable. Their livelihoods are more vulnerable to climate change. And putting those two together, those who contribute the least to greenhouse gases will be the most impacted by climate change. So that's a sense of the geographic disparity of the climate of the unfolding climate change, but it's not just a disparity between those nations and this nation, but there's also a disparity within nations. And poor people who haven't done much emissions or who are not responsible for many emissions, poor people within rich countries are also more vulnerable. And I apologize for this slide, but this is a couple from Katrina who were left behind in New Orleans, and he was on oxygen, and before they made their way to safety, he simply ran out of oxygen. So poor people, even in rich nations, are vulnerable. There's also the big disparity between the emissions that we're doing today and the burden falling on people in future generations. So last time looking at this slide, but to get a sense of where we're going to be in 2030, and I picked that date because that is the Paris Agreement of 2015 set targets for 2030. And at the bottom you see the United States and what our emissions have been up until about 2014, and then what commitments we have made going forward. The blue is the same thing for the European Union, what their emissions have actually been up until roughly the present, and what they committed to do in the future. And then the Chinese as well. The good news about China is that Paris was the first time that China agreed to having any limit on their emissions. So even if, and I don't like that. I don't like starting that sentence that way. Given that we will all meet our Paris commitments, what that does is it just leaves that bit there where the arrow's pointing. That represents the emissions that are available to the rest of the world for all of us to stay within the carbon budget. And that rest of the world is about 70% of the global population. So even if we meet our commitments, there's still a big challenge for the globe as a whole. So I can't see you, just by the way, because of the lighting, but I'll pretend that some of you are about in my age range, and so I'm not going to be here to experience the very worst of climate change, but many of our younger students will be. And so I'm giving them the lifespan of 1998 to 2080. And so this is a really special generation that's in front of us in many of our introductory classes, in that they are going to have to deal with some of the catastrophes associated with climate change unless they themselves work to prevent it. So they're on both sides of it. They're going to experience it, but also they are part, or could be, part of the solution to mitigating climate change. In my view, to be Educators, relevant to this perilous moment, we must alert our students to the economic and ethical challenges of climate change. And so finally, I leave my students with more questions. I hope you notice I haven't answered any questions, and I do not answer these questions for my students as if I could, right? All I can do, though, is bring the questions forward, and I can require that they at least talk with one another about them. And so these are my last questions. What must we do to achieve the very ambitious technological progress? I love this number 2. I didn't make it up, but I pass it along. Do U.S. consumers bear any responsibility for Chinese emissions when we consume the Chinese products? Number 3, is it efficient for heavy emitters to shift costs to others around the globe? Our externality model says that is not efficient. Is it equitable? Number 4, in today's world, what is the positive outcome of burning more fossil fuel? What is the negative outcome? And the last question is purely rhetorical. I've never asked any student to answer it, but I put it before them. Should we fail to avert climate catastrophe, I say to the students, in 2070, when young people ask you what you were doing in the key decades that the climate fate was sealed, what will your answer be? So you have in your packet a handout with some of these slides on it, and it also includes a very, very long web address, and you can find this entire slideshow with some notes and with some references at that address. I am absolutely delighted to talk about climate change, apart from the science, and about how to teach climate change. So I welcome any comments, conversation over the next day, or questions.